Okay, now in this video, let's talk about how to calculate the Gibbs free energy. In the previous video, we have talked about, I've introduced the Gibbs free energy, what it is, and how to predict it when the enthalpy change is given to you and T delta S is given to you. So now here we will be calculating. That's the second type of question which comes here. So in order to calculate, we have the same formula that delta G. If we need to calculate it under standard conditions, so we need to have the delta H, okay, mentioned in the question, and we need to have a delta uh, S, which is an entropy. Okay, and because these are being calculated, these are the values at the standard conditions. So definitely we are going to take the temperature as 298 Kelvin, or we are going to take it as 25 degrees Celsius. We will either take it as 25 degrees Celsius or we'll take it as 298 Kelvin, right? So values which are given in the question, we are going to put it up in this formula and we will compute. Now, because the entropy is always taken in joules per Kelvin per mole, whereas the enthalpy we have kilojoules per mole, so we will be converting them into the same units, right? So in order to convert it into same units, what we'll do is we will be multiplying the enthalpy, which is there in kilojoules per mole, by changing it by multiplying it by 1000. That is how we can change both the terms into joules, right? And the temperature, because the unit for Gibbs, again, the standard conditions, as I already said, the temperature has to be taken as uh, the temperature need to be taken as in 298 Kelvin, because entropy is all, the unit for entropy is joule per Kelvin per mole. So that is why we are taking the temperature here in Kelvin only. Now let's do some of the worked example and then I'll give you the questions to solve. Okay, one more thing before we move on to the calculation, we need to understand, just like your enthalpy change for an element, right? So enthalpy change for an element is basically taken as zero. Similarly, the Gibbs free energy of formation for an element is taken as zero, right? Under standard conditions, so it is taken as zero. Whereas the Gibbs value for the rest of the compound, that will be mentioned, that will be given to you people in the question. So here comes the first worked example. So I'm reading out the question here. This it says that calculate the Gibbs free energy change for the decomposition of zinc carbonate at 298 Kelvin. So this is the equation given to you, and the equation is a balanced equation, and along with that, delta HR value is given to you, which is a positive value, which is indicating that it's an endothermic reaction, right? Because it's an decomposition reaction, so heat has to be given in order to break it down to simple substance. Now apart from that, the delta HR is given to you. Then apart from that, what else we require in order to calculate the Gibbs is basically the entropy values. Now, the entropy values for carbon dioxide is mentioned over here, for zinc carbonate is given to you, and for zinc oxide. Now, that means the entropy of the system you have to calculate. And how do you calculate entropy of the system? By subtracting entropy of the product, and from the product you will be subtracting entropy of the reactant. सही है, तो इन दोनों वैल्यूज को आप सब्ट्रैक्ट करेंगे तो एंट्रोपी ऑफ द सिस्टम मिल जाएगी. और एंट्रोपी ऑफ द सिस्टम को आप कौन से फॉर्मूले में डालेंगे गिब्स फ्री एनर्जी चेंज को कैलकुलेट करने के लिए? यू आर गोइंग टू सब्ट्रैक्ट फ्रॉम डेल्टा एच आर टी डेल्टा एस. तो यहाँ जो ये वैल्यू आ जाएगी वो आप इस फॉर्मूले में डालेंगे. टेम्परेचर यू ऑलरेडी इज बीन गिवन टू यू 298. डेल्टा एच आर की वैल्यू इज ऑलवेज also given to you as positive 71.0 kilojoules. Now this kilojoules you need to multiply by multiplying by 1000, so that both the values are in joules, right? Temperature you'll be taking in Kelvin. So when you have all the values here, so you will compute it and you will be getting delta G over here. So let's see what are they doing. They are, the first step, they are converting the value of delta HR into joules per mole. So they're just simply multiplying it and they have got a positive 71 thousand joules per mole. That's the conversion they have done. Step 2, they are calculating the entropy of a system. Now what they're doing is product minus entropy of product minus reactant. So the values are already there. So they're getting, after computation, they're getting plus 174.8 joules per Kelvin per mole. That's a unit for entropy. Now they have both the values there. They will be putting those values into the formula. The formula is delta HR minus T delta S. So they'll be putting, and they're getting positive 18,909.6 joule per mole, right? अच्छा, उसके बाद इन्होंने unnecessarily they have again converted that by kilojoule, converted that into kilojoule by dividing it by 1,000. So basically they're getting the answer positive 18.9 kilojoules per mole. Okay, so that is the very simple way of calculating, and because it's a positive value, so the Gibbs value is a positive, so we say that the reaction is spontaneous, is not spontaneous, because Gibbs value, if negative, it's going to be it's not spontaneous at the room temperature pressure, and we already know that this is a thermal decomposition reaction, so you have to eat it. So on as stated in the question, so दोनों चीजें coincide कर रही हैं कि ये decomposition reaction है, for which we know that कि उसको heat देना है, तो 298 पे वो definitely non feasible non spontaneous reaction होगा. जब तक आप उसको temperature नहीं देंगे तब तक reaction proceed नहीं होगा. So here is a question which you can practice, take a snapshot and work it out. Now there are five parts to it, and here you have to calculate the standard Gibbs free energy for each reaction A, B, C, D, E. The entropy values in order to calculate the entropy of a system. The values are mentioned here. The delta HR is mentioned with each equation. You know the formula, place the values of delta HR, and after calculating entropy of a system, place it in the formula and compute it. Make sure that you convert the units properly, right? So this is the question. Attempt all five parts and then you check your answer from this particular slide. This is question number 8, part A. It's the value is minus the value for A part is minus 208 kilojoules per mole, right? And for the next part, I'm lowering down the slide. For the next part, part B, the next answer is basically your it's minus 818 kilojoules per mole, right? This is for the B part. Then for the C part, the answer is minus 448 kilojoules per mole. The next we have for the D part, it's minus 609 kilojoules per mole. And for the E part, we're getting positive 31.4 kilojoules per mole. Kindly tally your answers. If anything is going wrong, please check the steps which are mentioned here. Proceeding further. Now we know how to calculate the Gibbs energy if the enthalpy change of a reaction and entropy is given to you. But now moving on to the other type of calculation. If they ask you to calculate the Gibbs free energy change of a reaction or one particular reaction, then like for example, if they ask you to calculate enthalpy change of a reaction, then what do? We subtract whatever the enthalpy of the products they have given you, and from this value you subtract the enthalpy change of a reaction. Similarly, Gibbs free energy change of a reaction, similarly you'll be using the same formula. आपको अगर reaction का Gibbs free energy of a reaction calculate करना है, तो आपको गिव्स फ्री एनर्जी ऑफ अ प्रोडक्ट में से आप रिएक्टेंट को सब्ट्रैक्ट कर देंगे. ठीक है. नाउ रिमेंबर फॉर दिस पर्टिकुलर थिंग, सो यू हैव द टू डिफरेंट टाइप ऑफ कैलकुलेशंस. दे आस्क यू, एक कैलकुलेशन के लिए अगर आपको एंथैल्पी चेंज और एंट्रोपी दी हुई है तो आप पहले वाले फॉर्मूले से वहां कैलकुलेट करेंगे, और अगर आपसे गिव्स फ्री एनर्जी चेंज ऑफ अ रिएक्शन पूछ रहे हैं और आपको मुख्तलिफ गिव्स एनर्जीज दी हुई हैं रिएक्टेंट एंड प्रोडक्ट की, सो यू विल बी सब्ट्रैक्टिंग प्रोडक्ट में से रिएक्टेंट in order to find out the Gibbs free energy of the reaction. Now for this, always remember you need to have a balanced equation, right? Number two, तो सेकेंडली आपकी बैलेंस्ड इक्वेशन होनी चाहिए, तो ताकि वैल्यू गिव्स की जो भी है, प्रोडक्ट की जो भी है, आप उसको उसी फॉर्म में मोल्स के बेसिस पर यू हैव टू टेक अकाउंट ऑफ दैट, राइट? लेट्स डू few questions so that you people understand how to cope up with such scenario. So this is a worked example. I'm reading the question. Draw a Gibbs free energy cycle to calculate the standard free energy. So they're asking you to draw it. So drawing is the same. If the equation is NaHCO3 is giving you these products, so reactant ये आपके reactants हैं, ये आपको product मिल रहा है. Reactant when converts into the product, like enthalpy change of reactions, that is Gibbs free. सीधा से ये Gibbs free energy of a reaction है. Or you can form either the reactants from the elements, or you can form the products directly from the reactants. और ये आप cycle direct route और indirect route करके और आप उसको cycle में convert कर देते हैं, ठीक है? So this is how you draw the cycle. Now the values I mentioned to you, and you have to calculate the Gibbs free energy for a reaction. So taking care of the stoichiometry of the values, the molar ratio and all, we have all the values, they are mentioned over here in the question. You will put the values in the formula, that is delta G product minus delta G of the reactant. So this is product minus reactant. You'll put all the values and you'll compute, and on computation they're giving you the answer positive 25.9 kilojoules per mole, right? So because it's a positive value, so this reaction will be non-spontaneous or it's not feasible. We know that this is a decomposition reaction, so it will not take place at the normal room temperature pressure. So we need to heat it up. So when you increase the temperature above the room temperature, then it's going to be a negative value, then only it's going to be a feasible reaction. One more thing, like I've shown you the slide prior, gives free energy for the reactant is always considered as zero. For the elements, ठीक है, जो आपके elements जो होते हैं उनके लिए उनकी जो gives free energy for an element is always taken as zero. Like you have the enthalpy change of an element is taken as zero. Similarly, आपके gives free energy of an element will be also zero. लेकिन entropy की अगर बात करें, entropy of an element, अगर आपके दो एलोट्रोपिक फॉर्म्स भी हैं, डायमंड एंड ग्रेफाइट भी हैं, तो एंट्रोपी इज जस्ट अ डिसऑर्डर. तो डिसऑर्डर वेरी करता है, तो डिसऑर्डर के बेसिस पे इट्स अ मेजर ऑफ डिसऑर्डर द एंट्रोपी. तो इवन एलिमेंटल फॉर्म में भी उनका डिसऑर्डर होता है, उनका उनका अरेंजमेंट ऑफ द पार्टिकल्स होता है. तो एंट्रोपी की एक वैल्यू फिक्स होगी हर एक एलिमेंट के लिए, ठीक है, अगर वो गैसियस स्टेट में एग्जिस्ट करता है या लिक्विड में या सॉलिड में. लेकिन गिव्स फ्री एनर्जी विल बी जीरो for the elements. Like you have delta H for an element, delta H enthalpy change, delta H of formation for an element is zero. Similarly, this is also zero. Coming to the next question, similarly they're asking you to calculate the standard Gibbs free energy of the reaction between hydrogen and oxygen. The values are mentioned here. You have put up the values here and done the computation. Product में से reactants निकाल लिए, and you're getting minus 546.4 kilojoules is the energy, and this is a negative energy, so that is indicating that the reaction under the standard conditions is basically your spontaneous reaction. Okay, moving ahead. So this is a question. So this is a question which has got 5 parts. Kindly attempt all the 5 parts and tally your answer, which I'm showing on, which is on the next slide. So these are the answers to your previous slides, right? So please, the question number 1 has got an answer that's minus 305.6 kilojoules per mole, right? Then second one is basically it's a positive 169.0 kilojoules per mole. The third one is minus 1138.8 kilojoules per mole. And the down there, it's slightly, okay, I'm going right. So this is again your minus, it's minus 225 225 2.6 kilojoules per mole, and the E part is your minus 660 kilojoules per mole. So these are the values for the parts of of the previous questions, right? All right, going ahead. Okay, now it says that the Gibbs free energy change and the direction of the chemical change. So that means they are talking about when you have the reversible reactions. अगर आपके पास reversible reaction है, so the reversible reactions they are going to attain the equilibrium state. तो at the equilibrium, because the reaction जो भी value है आपकी forward reaction की और जो backward reaction की, at the equilibrium that is going to be cancelled. So Gibbs free energy at the equilibrium state is going to be your zero. So Gibbs free energy for a reversible reaction at the equilibrium state is going to be zero. क्योंकि जो भी forward reaction की जो होगी वो value और backward की जो होगी वो cancel out हो जाएगी. Then अगर आपकी Gibbs free energy for a reversible reaction is coming negative, right? तो इसका मतलब है आपका जो है रिएक्शन जो है the equilibrium is basically shifted onto the right hand side. तो आपके predominantly you have more products being formed. So that is why you have a negative value there. If it is a positive value, that means aapka jo equilibrium shift hai, that's towards the left hand side. That means predominantly you have the reactants more. That is the reason the Gibbs free energy is a positive value. Okay. One more questions they ask you is that if the reaction that at what temperature this any reaction which is a reversible reaction will acquire the equilibrium state. At what temperature the reaction will acquire equilibrium state. So basically we know that the Gibbs free energy at the equilibrium is going to be taken as zero. Okay, so automatically we will be having delta HR, it will be 0 minus T delta S. And if we need to calculate the value for T, so we will be basically हम इसको जो है rearrange करेंगे. So we will we will rearrange this the remaining part of the formula in order to calculate the value of temperature at which the equilibrium will be acquired.